Okay. Some important compounds of carbon and silicon. Out of this, we need to discuss about the few important compounds: carbon monoxide, carbon dioxide, and silicon dioxide, silicones, silicates, and zeolites. So we'll see one by one. First one, carbon monoxide or carbon monoxide. How carbon monoxide is prepared? It is prepared by the direct oxidation, or carbon is treated with oxygen and limited supply of air. Carbon treated with oxygen and limited supply of air will be forming carbon monoxide. So we can able to write equation C carbon treat with oxygen O2 will be forming CO, C2C plus O2 give rise to 2CO, carbon monoxide. So this direct combination or an oxidation, the burning of any substance, that is an oxidation. So heated means carbon is mixed with an oxygen at high temperature, will be forming carbon monoxide. So with the using of oxygen, limited supply of air condition, otherwise will be forming. So O2 is limiting here, limited supply of oxygen will be using. If you use an excess, it turns to in carbon dioxide. And also the formic acid, okay, the formic acid HCOOH is an formic acid. Formic acid HCOOH is treated or in presence of sulfuric acid. It is reacted in presence of concentrated H2SO4 at 373 Kelvin will be forming carbon monoxide CO and H2O. This is another method of preparation of carbon monoxide. And also carbon treat with the water means hydroxide. So this is again further high temperature because of stability. 473 to 1273 Kelvin will be forming carbon monoxide and dihydrogen. This is you studied in hydrogen chapter. Okay, so what is that? Water gas. What is that? Water gas or syngas. Water gas or synthesis gas. And also this carbon treat with oxygen or mixed with oxygen and also in nitrogen. So carbon mixed with oxygen and nitrogen will be forming. This is also high temperature and roughly 1273 Kelvin will be forming carbon monoxide CO and with the formation of nitrogen gas N2. If you balance that equation, 2CO and 2C, oxygen O, nitrogen N2, and this will be 4N2 and 4N2, and here is 4N2, two water molecules, no? So 2 and 2. So that is 4N2. So this is the balanced equation. The mixture of carbon monoxide CO and dinitrogen N2 is very familiarly known as producer gas. I hope a few of the students already studied this type of a reaction. So carbon treat with water will be forming carbon monoxide. Carbon monoxide with the liberation of dihydrogen gas. This mixture is known as water gas. Mixture is known as water gas or synthesis gas. Okay, and in the case of nitrogen, the same carbon, oxygen, nitrogen at high temperature will be forming carbon monoxide with the dinitrogen. The mixture of CO and N2 is called producer gas. The mixture of carbon monoxide and nitrogen. So CO and H2, water gas. CO and N2, producer gas. Need to remember the composition. Okay, so formic acid. The out of this, the familiar two important methods of preparations. The important method of preparation is carbon treated with oxygen. So limited supply of air or oxygen will be forming. Ashita will tell you, don't worry. C plus O2 give rise to CO, carbon monoxide. That too limited supply of air, limited supply of O2. So will be forming carbon monoxide. And these are the two methods you need to remember. And this already you studied, the CO and H2 will be forming in the water gas. And remember one more, CO and N2 mixture is called producer gas. Okay. So C plus O2 at high temperature will be forming carbon monoxide. On the small scale, it's prepared by the dehydration of the formic acid with concentrated H2SO4. Removal, separation of water. Dehydration means formic acid treated with a little amount of concentrated sulfuric acid at 373 Kelvin will be forming carbon monoxide. Dehydration water is removed from this. Okay, next. The properties. What are the properties of carbon monoxide? Carbon monoxide is a colorless, odorless, poisonous gas. It is insoluble in water, almost insoluble in water. So it is carbon monoxide is colorless, odorless, no color, no smell, poisonous. This factor is important. Poisonous gas. Why it's called poisonous, we'll see here in after the fifth point. And it is almost insoluble in water. And it acts as powerful reducing agent, which reduces almost all metal oxides, which reduces almost all metal oxides except alkalis and alkaline earth metal, because those will act as powerful reducing agent. No, so reduction is not, it's not possible. So it is impossible. So hence carbon monoxide normally used as powerful reducing agent. In carbon monoxide, C double bond O. Carbon monoxide, C double bond O. And after that, one is in sigma bond, another is pi bond. Okay, which will be consist of C double bond O. So CO, one sigma bond, and the one pi bond. In this, what happened will be one more electron, carbon, 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 oxygen, CO2. If you consider carbon and oxygen, CO2 will be double bond and double bond. Carbon monoxide will be triple bond. One sigma bond and two pi bonds. One sigma and two pi bonds between carbon and oxygen. This is the structure how it will be. CO, carbon monoxide. In dioxide, one electron will be shift here, will be forming double bond. In double bond, we'll be having one sigma and one pi bond. In triple bond, we'll be having two pi bond and one sigma bonds. And the carbon monoxide is porous in nature, highly porous, will be consist of small holes on the surface, highly porous. Hence, it can easily absorbs the gases, easily combines, easily take the oxygen gas with this and can able to form carboxyhemoglobin. So carbon monoxide is highly porous in nature, so it can able to form complex with hemoglobin. Carbon monoxide combines with hemoglobin will be forming carboxyhemoglobin. Carboxyhemoglobin is extremely stable than oxyhemoglobin. Carboxyhemoglobin is extremely stable. How much? Almost 300 times is more stable than oxyhemoglobin. So that is the reason it prevents the flow of transportation of hemoglobin to the red, means which prevents the transportation of oxygen, means hemoglobin act as transportation carrier. Okay, so it binds to hemoglobin and prevents the flow of oxygen. It causes sudden death, suffocation. From the due to that reason, we studied where the treating of cyanides. Same thing will be happen when they treated with cyanides. Okay, SN. Okay, and isocyanides, carbon with group carbon and cyanide CN, and sulfur in NC. CN is cyanide, NC is isocyanide. In both the cases, so the binding of oxygen is more. In both the side, it will be binds with oxygen, both carbon and nitrogen. Same like in carbon monoxide binds with hemoglobin, it will be forming carboxyhemoglobin. It prevents the flow of oxygen, so it leaves suffocation, the person will die. So hence it is called the poisonous gas. Okay, these are the property. So poisonous we called as a toxic. It is also we called as toxic. So from this, the person may die with the means over consumption of carbon monoxide. So that is prohibited. So how it will be prepared? There will be different methods of preparation of carbon monoxide. So limited supply of air will be forms carbon monoxide treat with carbon, and the treating of a small quantity of carbon monoxide also prepared with dehydration of the formic acid. Okay, and also can be prepared this carbon is treated with water and 1273 Kelvin will be forming carbon monoxide and dihydrogen is called water gas or syngas. And carbon, oxygen, nitrogen treat with the same temperature of 1273 Kelvin will be forming carbon monoxide and dinitrogen is called producer gas. Remember? Okay. So next, after this, so solid carbon dioxide, this is carbon monoxide. Solid carbon dioxide, we need to study about carbon monoxide. In the first equation, we studied carbon treat with oxygen will be forming carbon monoxide. If excess of carbon, excess of oxygen is allowed to mix with carbon, will be forming carbon dioxide, CO2. And CO2 is, we know that it a gas is gas. Solid carbon dioxide is called dry ice. Important, you need to remember. I think you already studied this. So solid carbon dioxide is called dry ice. So next important compound is, what is it? Carbon dioxide, CO2. Carbon dioxide, carbon dioxide. It is prepared by the complete combustion of carbon and carbon containing fuel. Not only a carbon containing any fuel like hydrocarbon. Hydrocarbon, methane on combustion gives carbon dioxide and water. So decomposition of calcium carbonate gives a carbon dioxide and water, calcium oxide and carbon dioxide. So how it will be, how we can able to prepare. This will be characterized the complete combustion in all the cases. So this will see C plus O2, excess of air or oxygen will be forming carbon dioxide, C plus O2, CO2 at higher temperature. Similarly, methane untreated with air means oxidation of methane at high temperature gives carbon dioxide and water. And these two are complete combustion. Complete combustion. Not only this, decomposition of calcium carbonate, CaCO3. CaCO3 decomposes. There is also high temperature. Forms CaO, calcium oxide, with the formation of carbon dioxide. So this is also a complete combustion itself, but this is not combustion. This is decomposition. There is another method of preparation. It's also called as a commercial commercial method of preparation, of carbon dioxide. Okay. Next, CaCO3. In laboratory, we can able to prepare carbon dioxide. How this calcium carbonate, CaCO3, treat with hydrochloric acid, HCl. Okay, will be forming calcium chloride, CaCl2 plus carbon dioxide, CO2 and water, H2O. Okay, this is what we call as laboratory method of preparation. Laboratory method of preparation of carbon dioxide. So these decomposition of calcium carbonate, commercial method of preparation. These two are complete combustion. That is a method of preparation of carbon dioxide, but that is complete combustion. Okay. So these are the methods of preparation of carbon dioxide, CO2. Solid carbon dioxide is called dry ice. So carbon and complete combustion with carbon with oxygen means oxidation of carbon gives carbon dioxide. Okay, and methane on combustion, hydrocarbon on combustion gives carbon dioxide and water. General equation. Calcium carbonate on decomposition gives calcium oxide and carbon dioxide, commercial method of preparation. Calcium carbonate treat with hydrochloric acid. Okay, so here H2, no, it's not balanced. two hydrogen, chlorine, two chlorine. So 2 HCl. So CaCO3, 2 HCl, give rise to CaCl2, CO2, and H2O. This is the laboratory method of preparation of carbon dioxide. Okay, so need to remember. Next up, we'll see the properties, what are the properties of the carbon dioxide and how it will be the structure. It is a colorless, odorless gas, and slightly soluble in water.